Hello, everyone, and welcome to BSidesSF. It is my pleasure to introduce Clint Gibler of TLDRSec, giving us the TLDR on applying AI to cybersecurity. Hi, Clint.
Hello. Hey, thank you all so much for coming. I'm absolutely thrilled to be here, and thank you to the organizers for having me. So this is going to be a fairly dense talk, so please hold your booze to the end. So my goal is to take like as many things out there in many different areas and put them into one place for you to easily reference. And I think I've done that pretty well. Okay, so this talk is also the subtitle, 2020 Clint Eats His Own Words. So this is a blog post I wrote with a friend where I said, you know, AI and security is overhyped. Obviously, a lot has happened since then. Okay, so I have two main goals. So one is to give you like a big picture understanding of the space, and then also a bunch of tactical examples in terms of tools, blog posts, talks, papers, so that ideally you can say like, oh, I can directly apply this at work, or maybe, oh, this other adjacent idea maybe thematically is similar to something I could do at my company. Okay, so there's so much I would like to talk about, but really, due to time constraints, I can only really talk about one, which is applying AI to cybersecurity problems, not really attacking or securing AI itself. Fortunately, there's many other good talks today and other tracks that will discuss that. Okay, so three main parts of this talk. First, we're going to do a lightning introduction to large language models to ensure we're all on the same page. The bulk of this talk will be on use cases, and then I'll conclude with some resources and reflections. And when I say use cases, I mean a lot of them within many different categories. And if you're like me, when you see that, you're like, ooh, okay, we gotta move. We got a lot to do. Okay. So some disclaimers, we're going to go very quickly. This is meant to be a reference. I have a link on the last slide to these slides, so don't feel like you have to write everything down. And also this talk is being recorded, so don't stress about it. Also, I'm going to reference some companies and their products. This isn't necessarily an endorsement. Some of the people I'm going to be referencing are direct competitors to my day job. The point here is I want to give you an understanding of the lay of the land. Very quickly, a little bit about me. So my name is Clint. I'm currently the head of security research at SemGrep. We have a popular open source tool. We also have a pro engine and more rules that give you better coverage on first-party code. If you care about third-party dependency security, we also have something that can find reachable, vulnerable dependencies, and a secrets product that finds not just like regex-based secrets, but sort of semantically, oh, this argument is a secret if it's a string literal and stuff like that. Before this, I worked at NCC Group, a global security consulting firm, and before that, I was an indentured servant, grad student at UC Davis. Okay, I also write a security newsletter that's totally free, just trying to send you the best tools, talks, blog posts and stuff straight to your inbox every week, once a week on Thursdays. Okay, so let's talk about large language models. Okay, so this is going to be painfully oversimplified. I'm just trying to sort of introduce some tools and vocabulary to make sure we're all on the same page. Okay, so simplistically, we can think of them as next word autocompleters. You create them by taking a huge amount of text, like everything on the internet, textbooks, things like that, throw a bunch of compute at them, like GPUs, and then sort of math and magic happens, and then they're suddenly smart. So there's many players in this space. Some of the main ones are OpenAI with GPT-4, Claude 3 by Anthropic, Google's Gemini, Meta's Llama 3, an open source model, Mixtral. Like there's many other players. Here's just a few. So a hallucination is when a model says something confidently that's not true. If you're building some LLM applications, you might want to consider using libraries like LangChain or Llama Index. They're quite popular. A prompt is basically a persona, like you are a security expert, some sort of task, like review this code, and then some sort of input, like the code that you want it to analyze. Few-shot prompting is basically the above, but you give it a few examples, like given this input, I want output like this. And this is actually surprisingly effective in practice. You don't necessarily need to fine-tune a model or do something more complicated to get pretty good results. A context window is basically how much you can pass to an LLM at a time. You can think of it almost like it's working memory. But sometimes you have too much that can fit into one prompt, and you want to, maybe you have a bunch of PDFs or transcripts or your company's internal help docs, something like that. So you could index those in a vector database and then use something called retrieval augmented generation, or RAG, to basically have the model like programmatically pull in the relevant context and then answer a question or perform some analysis over it. So an agent, basically, instead of just like, hey, given this prompt, give me this output, maybe you want to do some sort of multi-step analysis, maybe you want some sort of complicated planning or multiple agents all communicating together to solve some problem. Agents allow you to do that versus just single prompt and response. Tools let the LLM take action, such as do a Google search, make some API request, calculate something, run code, or use security tools, which we'll look at in a second. Okay, so that was a brief primer. So now, inevitably, when someone comes up to you in the restroom and asks you something like this, you'll be able to speak confidently. And of course, this is going to be literally every RSA bathroom. Okay, so quick note on notation. Just to keep things simple, I'm going to use the OpenAI logo, but I really just mean like generic LLM, just because I wanted to keep things simple and not like switch logos all the time on you. Okay, so let's get into use cases. So within sort of the static analysis AppSec space, I see two main things. So one is like the tool flags some piece of code, like, hey, this is vulnerable, and the model can make some prediction about if this is a true or false positive, like, is this something we actually need to fix? And then if so, here's maybe a code snippet that we think will fix it, so the developer can just say like, yes. So my colleague Bense wrote some nice blog posts about this. There's also AuxGPT. There's also this very excellent blog post by the GitHub Security Lab that I really wanted to emphasize because it talks about like what is the sort of pre and post processing you need to do to actually make sure the outputs of models are reliable and are just high quality. So definitely recommend checking out this blog post by the GitHub team. Okay, so maybe we don't want to just use some other tool. Maybe we want the LLM itself to find vulnerable code. So you could imagine this being like given a prompt and the code we want to analyze, mash those together, boom, we have some nice vulnerabilities. So there's been a bunch of blog posts about this. I think the Trail of Bits one, in my opinion, is one of the more thorough methodologies. But there's a number of challenges people have described so far, so I just wanted to highlight some of those. So one is the prompt quality really matters. Like if you make a change, is this actually going to make it better or worse? Maybe like the current thing you're looking at, it gets better, but maybe like 20 other examples, it gets worse. How do you predict like on new code that you haven't analyzed yet, how it's going to perform? Some people talked about there being high positives, high false positives. Could also be very costly. So one person discussed analyzing just 200,000 lines of code is costing $100. So if you've got millions of lines of code, that could be quite expensive. And also context windows, right? So let's say you have one function that calls another, Like how do you make sure you have the right files in the context? And at some point you're kind of just replicating static analysis. So I thought this tweet was funny, so I included it. Okay, so can LLMs just autonomously solve CTF or capture the flag challenges? This paper took a look at that. And not all of them, but it actually did not bad on some, which I thought was cool. Okay, so this paper, I think, at least from what I've seen, is the most rigorous analysis of can models actually do a good job analyzing source code for vulnerabilities. And what's interesting is, so they took a look at various data sets that people were using and found that they had significant shortcomings in terms of the data quality, label accuracy, stuff like that, such that they concluded that many evaluation methods didn't seem to be very representative of real vulnerability detection. However, they did release a new data set, which I've just linked. It's on GitHub. So hopefully, like future work can hopefully have more interesting results. But one of their takeaways that I thought was very interesting is even with advanced training techniques and larger models, such as GPT-4, we found the results were akin to random guessing in terms of identifying these vulnerabilities. So I think this is still potentially a promising space, but at least this measured look that the authors of this paper did said, this is maybe today not the best application. So a talk by Louis Barrett, he gave at LastCon for like using small models or like open source models for various AppSec purposes. We're going to reference his work a couple times in this talk. If you wanted to set something up so that you had like automated like comments on new PR requests using local model, we don't have time to get into the details, but it's here in these slides. He sort of walks through what that might look like. Okay, so this I thought was kind of funny. So when they released ChatGPT plugins, they were actually using ChatGPT itself to analyze them for various like security or sensitivity properties. So their prompt to do that leaked. So yeah, when I saw that, I immediately couldn't help but think of sort of the Yo Dog meme, like using AI to analyze sort of the security properties of AI. Okay, so maybe you're like, yeah, like finding security issues is cool, but like, couldn't you just exploit that for me? Like that would be more rad. So this blog post takes a look at like what would that look like. So let's say you have a CVE report for like, this version of this library has a vulnerability. You could then programmatically extract the diff because, in this version it's vulnerable, in this version it's fixed. So from that, there's probably a set of file differences, like these things have changed in those commits. You could pass that to an LLM to say, given this issue, which of these diffs is most likely responsible for it. You could then programmatically generate maybe a vulnerable Golang program that exhibits that vulnerable functionality, and even have a Python POC that exploits it. So if you read the blog post, it's very much like the author had to cajole the LLM to actually do the right thing. So it's not like as streamlined and nice as I've made it look like. But I think this is overall an interesting approach. Okay, so this paper got some hype recently, claiming LLM agents can autonomously exploit one-day vulnerabilities, even 87% in their study. So, have we done it? Are we just going to let this loose on the world and it's just going to wreck everything? Well, it turns out no. So there was a nice rebuttal blog post by Chris Rolfe, who's an awesome security researcher who I recommend you follow, pointing out some sort of methodology things that I'll talk about in a second. And then one of the co-founders of CVE was also like, like maybe not exactly like that. So what were their concerns about this paper? So one is that there were only about 15 CVEs, so that's not necessarily representative of all CVEs. And then also, basically, each of these CVEs had a very easily Googleable proof of concept exploit. So rather than necessarily looking at the code or interacting with the app and then like from first principles, creating the exploit, it was more like, oh, cool, I know it's vulnerable to the CVE. Let me Google for a nice POC from that, and then boom, plug it in, like I did it. So I think that is useful, but I just think that's different than what was actually claimed by the papers. And someone in the tweet thread included this meme, which I thought was funny. Anyway, so I include this not to say anything negative about these authors, because I think anyone doing work that's pushing the industry forward is awesome, and that's very admirable, and it helps all of us. But rather to point out, like if someone's making a big claim, it's useful to think like, okay, like what was their data set and methodology and evaluation, and does that actually make sense? Okay, moving right along, penetration testing. So we talked before about agents and tools. So for example, letting it talk to a weather API, but we are security professionals, so why not give it access to security tools like Nmap, Zap, Nuclei, and more. Okay, so Matt Adams had a nice talk that I'm going to reference a few times. So he described it, you can imagine saying like, hey, I want you to do like a web app scan of this URL or this application. So then the model looks at the various tools that it has access to and it's like, okay, to accomplish what you just asked me, I'm going to run this one. It stores the results and then thinks for a little bit like, okay, given you wanted me to do this, this is what I know so far. Should I maybe continue and use another tool or just iteratively work like that? Or maybe I'm done and I can write a report that maybe even has a nice executive summary tying all the findings together. So there's been a lot of work in this space. So there was an academic paper that released their proof of concept code. There's also a GitHub repo that links another bunch of proof of concept tools. Okay, so how would I improve this? I think the things I've read have like one or two tools, but we have lots of security tools, so why not give them access to more, like SQL map, burp, and things like that. Another thing I've seen across many applications is rather than having like one agent with like 50 tools, sometimes it can get confused and not know like which tool to use. So instead having many agents that all collaborate, maybe and report to like a supervisor agent node that, this person is like attack surface monitoring, this person is like crawling web apps, this person's like SQL injection, stuff like that could make it more reliable. And yeah, storing the results somewhere that all the different agents can collaborate on would also be cool. My friend Joseph Thacker, or Rezo, wrote a blog post in which he claimed, I think these AI hackbots will outperform humans at some point, and then listed a number of companies currently working on this, so still early stages. I think my prediction is that it seems, so I have a security consulting background, and it seems feasible that within the next 2 to 3 years that some AI system, as models get better, as the sort of tissue around it gets better, that I think it could be as good as an entry-level pen tester. Like, not someone who's very experienced, but let's say like smart new grad who has like 1 year on the job or something like that. Okay, so moving on to threat modeling. So Matt Adams talked about and released this tool called StrideGPT, where basically you can put in the description of the application. Is it internet facing? What sort of sensitive data does it have access to? Is it a web app or something else? And then it sort of pops out a threat model, attack tree, and various mitigations. So that's like provide a bunch of info and then get something out of it. What if we wanted to have a more like collaborative conversation? So John created this custom GPT by uploading a bunch of information about, here are some cloud native risks, here are some best practices, here are some gotchas and things to look out for. And then you could imagine putting that same info in, maybe even uploading some docs. And then it could ask clarifying questions. You could sort of discuss and have sort of like a back and forth with it. Okay, so there's been a lot of blog posts in this space. I think one thing that I wanted to call out in particular is this GitHub action by Marcin. So basically it looks at the README in a GitHub repo as well as maybe other markdown files that are like describing what the repo does. And then it automatically, for example, creates a PR that's like, hey, given what I know about the application, here's maybe some risks you can consider and things like that. And you can imagine it programmatically updating based on new code pushes to the repo. So I thought that automation was neat. They also compare the output on like Claude 3 versus GPT-4 and stuff like that. I think this is still nascent. I would like to see more comparisons between models across many different situations, but I think that's cool. Okay, so you might think like, this is cool, but I'm busy. Could this be even better? This is how I think it could be improved. So there's a lot of information that we want, and I would argue that pretty much all of it we can gather automatically, or at least mostly automatically. So there's probably a description about what this app does in terms of like a design doc, a PRD, something like that. So why don't we like reach out to Notion, Google Docs, something like that, and pull that in automatically. Other things about the application, such as, is it a web app? What sort of data does it access? Things like that. Again, we can maybe extract that from the description using an LLM, or maybe do some sort of lightweight code analysis. And then is it internet facing? We can probably also figure that out via, again, the description, some sort of code analysis, looking at the Terraform, infrastructure as code config, talking to the cloud API, stuff like that. So the idea is like, how do we empower developers to move quickly and safely? So how can we save them time? Maybe we can just gather most of this automatically. And then, and I think this is kind of important, like, can we just present them like, hey, this is what we think is right, like, do you agree? And then it doesn't need to be perfect because editing is easier than writing from scratch. So the goal here is saving time, like not having a blank page. Okay, so also speaking of saving time, like creating an architecture diagram from scratch can be difficult. So why don't we just take the description and try to auto-generate as much as we can of the diagram. Again, it doesn't have to be perfect. It can just be close and the human can tweak the last final way. Okay, so security design review. This means different things to different people, but just to sort of simplify for the purposes of this talk, just to differentiate from the threat modeling stuff we just talked about, sort of just like, does security need to look at this thing? Like, how much do we care? So Louis, again, had a nice part in his talk about this. So the idea is like, okay, so developers come with PRD or scope doc or something like that, and the security team has defined either in a policy or a prompt or something like that, these are the things we care about. Are you making authentication or authorization changes? Are you accessing this type of customer data? What sort of things are you doing? And you could imagine a model sort of combining those two to then have a overall risk score that's like, oh, maybe you don't need to look at this, or a security team should look at this, but later. And I'm going to share a couple of things the OpenAI team has been doing with LLMs for their own internal security, but I wanted to highlight that Fotis and Paul are giving a talk about that in more detail right in this room right after this. So I think it's going to be an awesome talk, so I highly encourage you to stick around and listen to it. So the things I'm going to be pulling from are from Karthik, one of their colleagues, gave a keynote that was really excellent recently, mostly about like paved road, hypergrowth companies and stuff like that. But there was like a little AI section at the end that I'm going to quickly pull from. So similar to what Louis was talking about a few slides ago, they built a Slack bot they called SDLC bot, where a developer can similarly say, this is what I'm building, here's a link to the docs, and answer a few questions, and then it sort of outputs like, okay, does the security team need to look at this, yes or no, or maybe later. So triage bot, sometimes potentially sensitive things happen, like a Google Doc labeled confidential gets set to publicly available. So you could have a bot that automatically messaged the person. It's like, hey, was this you? Was this intentional? Can we fix this? And sort of taking first line triage out of the way for you. Maybe lots of people are asking questions in the security channel, and you can automatically point them to the right sub-team. Or even if there's common questions, like provide that to the model to just answer immediately, maybe using RAG or something like that. If you have a lot of bug bounty submissions, you might want to automatically classify like, is this in scope? Is this out of scope? Is this maybe some sort of functionality bug and not actually a security issue? So you can use it for that as well. Access management can be tricky. So let's say someone's trying to do something, they get blocked, they don't have the right permissions. You could help them troubleshoot like, oh, you need to be added to this group, or help them get their job done, but still in a least privileged way. So they actually open sourced 3 of their Slack bots, which I've linked to on GitHub here. But what I'm trying to get at is there's a lot of things I'm going to discuss in this talk that are like applying LLMs to security problems. But I think what's cool about some of these is it's really like like at a meta level, it's like, how do we improve like operations or communications or like processes around things to free up security teams to do more things? So in terms of like classifying, okay, bug bounty submissions, is this in scope of our program or not? For asking questions in Slack, like which team bucket does this go into? For answering questions, maybe in the security channel, you build up a document of like, our top 10 most asked questions are this, so let's just answer those automatically. So for the SDLC spot, perhaps there are some secure by default libraries or infrastructure you've built that you want developers to use. You could imagine as people are proposing new things, it could almost be like a just-in-time education bot that's like, hey, it looks like you're spinning up a new Golang microservice. Here's like an auth library we built for you to just do that. Or, oh, it looks like you're talking to this database. Here's how to do that securely. So just like sort of being everywhere, helping developers both move quickly and knowing the things that you've built for them. So again, like not just applying LLMs to security, but also reducing the operational toil of security teams so they can invest in higher leverage activities. Okay, so some blue team applications. So this is again by Matt Adams. So the idea is you enter your industry and your company size, and then given what it knows about various attack groups, it can say, hey, here's some incident response scenarios that you specifically at your company might want to consider. So the MITRE folks released a tool called TRAM. So given a threat intel report, or perhaps a PDF, it can extract the techniques, tactics, and procedures from that, so the TTPs. A blog post that talked about a bunch of things, I'm just going to highlight 2 of them here, is by Thomas. So basically, he loaded the information from MITRE attack groups, which is sort of documentation on here's a bunch of different threat actor groups, here's what they're doing, loaded that into RAG, and then in sort of like a Jupyter notebook type thing, he can then ask English questions of that, like what is this Lazarus group? What sort of techniques do they use? So this is very similar to other use cases in terms of like asking questions of books or other large documents, but I think is cool when like that documents you're asking questions of are security. Another application he talked about, so there's this threat intel library by Microsoft called MSTICPY. that has various functions it exposes, like given this IP address, talk to virus total and let me know what it knows about it, or given this malware sample, like, just give me what you know about it. And then he basically exposed those library functions as tools, gave them to an agent so the agent could call them itself. And then it's in sort of a React loop where it can think about what to do, take some action, observe the results, and then maybe take another action from there. So I think this is really cool. Like imagine maybe APIs or tools your company has. What sort of security functionality would it be interesting to sort of give as capabilities to an agent? And this sort of SOC analyst as a service, or like a SOC analyst AI bot, seems to be a very hot area right now. There's at least 5 or 6 startups all working on this right now. So another example, maybe you're like, okay, this is a lot of text about this threat intel report. It would be nice to just have like a intuitive visual understanding of it. So Thomas released a Jupyter notebook that walked through how to turn that into a nice Mermaid.js visual diagram. Okay, so that's like text to image. What about video to that? So my friend John Hammond had a nice video about this specific Apex Legends hack. Maybe I wanted a nice overview of it, so I could use this pattern called create investigation visualization, where I go from YouTube to transcript, pass it to this prompt, and then again it generates a nice Mermaid.js diagram for me. So this is using a fabric pattern, which is basically this really cool open source project that's by my friend Daniel Miesler, who's actually sitting here, so shout out to him. And so there's a bunch of like productivity type things, and there's also like if you're a security professional, there's prompts that you can just use now for free. Okay, so Microsoft's Security Copilot has functionality where it's like, given this malicious script, explain it to me. Similarly, the Gemini Pro team from Google also is like, hey, give us this malware sample and we'll pick out what sort of activities is it doing, like clipboard monitoring and so forth, IOCs, things like that. Okay, so we talked about extracting TTPs from text, but what about from images? So most frontier models are multimodal, which means they can understand images. So you could also extract, say, IP addresses, domains, URLs, other IOCs from threat intel reports, the images in those reports. So this tool demonstrates that. Another example is, let's say you have a dump of discussion on like a dark web marketplace, or maybe a Discord or Telegram channel for like cyber criminals or APTs or something like that. And you might want to know, okay, what are they talking about? What are they planning? What's going next? So kind of summarize it. Or maybe it's in another language and you want it in a language you understand. So what I think is very interesting about that use case is it's pretty much the same as like otter, zoom, and descript, right? Like anything that's like, hey, you just had a meeting, here's the core takeaways, or for like a YouTube or podcast, like here's sort of the show notes. Like that actually same functionality when applied to, let's say, cyber criminals or APTs talking, and you just want to quickly understand what they're doing. It's kind of the same thing, right? It's just summarization. So I think looking at other domains that LLMs are doing really well in and think like, what is the security use case equivalent, to me seems very promising. Okay, next topic. So there's been a lot of work in using LLMs for automatically writing unit tests. So this is a paper from Meta. This is another paper. And there's also many open source tools like TestPilot. I think there's a number of like commercial companies that are maybe trying to do this as well. So I don't know about you, but when I see things like this, I get really excited. And the first thing on my mind is that I should really spend more time connecting with my family and friends, and stop spending all my nights and weekends reading about cybersecurity, and have more of a life. But no, of course you push that feeling down and ignore it, and instead you think fuzzing. Okay, so the first thing I saw in this space is from Google. So they're already running OSS fuzz, so they're fuzzing many open source projects continuously. And the sort of key idea is, okay, looking at the coverage reports we already have, okay, we don't see this code path being exercised. Let's pass this code to an LLM and then have it generate a sort of fuzzing test harness that then executes that path. So they also released that tool, which I've linked down at the bottom. And then CI Spark, I think, is sort of a commercial version of that. Okay, so what about fuzzing kernel code? So this was a neat blog post that walked through using syscaller and sort of an interactive communication with the LLM to do that. So I thought that interaction was cool. So it's sort of like, hey, I'm thinking about fuzzing this ioctal. Do you know about syscaller? Tell me a little bit about it. And then it's like, okay, yeah, it responds, and you're like, this makes sense. Okay, can you write in a little bit more detail how you might write a fuzzing harness for this? And then it does that. And then you're like, okay, this is looking good. Can what are all the ioctal syscalls that KVM has exposed? And then it actually does an internet search to look at the docs, and then it comes back and sort of returns a more detailed response for you. So the author found that the manually written test harnesses that they had written themselves was like higher code coverage, but the point here is that this workflow requires much less expertise and much less human time and effort. And overall, I just think this like back and forth flow rather than sort of unidirectional is interesting in terms of you're sort of collaborating with the LLM, and then as needed, it then reaches out to the internet to read the docs or gather other information that makes its responses better for you. Okay, so this was a very nice blog post from the Kudelski security folks. So basically they looked for the top 50 Rust parser libraries. They then filtered out those that were already fuzzing or they couldn't build, and then sort of automatically started fuzzing those projects. So when you have a project that's not fuzzing already, sort of the obvious questions are like, well, which parts do we fuzz? How do we call that code? Like, what does valid code calling this library look like? So I thought their methodology was really interesting. So like, how do you know how a library should be called? Well, you can look in like the README for usage examples, or maybe there's an example directory or unit tests or the benchmark folder, or even use some sort of lightweight static analysis that pulls out public functions and maybe also how it's called within the code base. So they found that they could generate at least one useful fuzz target for almost all the projects. They found at least one bug in over a third of the projects, not necessarily critical ones, but still free bugs are cool. And they also released their tool as well. Okay, so this is maybe one of the coolest ones. Perhaps some of you have seen this already. So Moyux, who I believe is a professor who sort of specializes in fuzzing, found a small C GIF decoding library on GitHub, passed it to Claude 3 and said, hey, please write a Python function that'll generate GIFs that exercise this code really well. So again, it's like a small code base, but that generator got a 92% line coverage and found 4 memory safety bugs and 1 hang, right? So like just totally like, hey, write me a thing to find bugs, and it did. And then as a point of comparison, he manually wrote something in an hour that actually had about the same performance as Claude got sort of 0 shot. So I was like, well, that's pretty cool. Another reason why I'm calling this out is he also did a really good job sharing, this is the prompt I use, this is the Python code that was generated, here's the GIFs that it made, here's the coverage that it got, like here's a detailed diagram, as well as comparing it to AFL+. And he just really shared all this information in a way that's really reproducible and nice. So in this talk, I've called out a number of areas it's maybe not, it's maybe overhyped in this area or not as good in this area. But sometimes you see stuff like this and you're like, that's pretty cool. Like, it actually did quite well. Again, that's just one use case. We need to try fuzzing like many more things, but again, I think that's quite neat. Okay, so reverse engineering. I've seen most things are sort of within the help explain this code to me or help me in the decompilation or maybe find bugs. So there's been a lot of tools in this space. Most of these are integrations or work with IDA Pro or Ghidra or Binary Ninja, things like that. And I'd say they're mostly prototypes more than things that have been thoroughly built out, but I think it's still quite interesting. Okay, so auto security domain specific language. Let's say you're not that great at writing SQL, like me. So for this tool, you could enter your database schema, ask some sort of question in English, and then it'll auto-generate some SQL for you. So that's pretty nice. The Pinterest team recently released a blog post in which they also built something like that. And they showed, here's our initial approach. They did some iterations. And then they came up with a slightly more complicated architecture. But what I like about it is they we're very forthcoming with like, here's the architecture we used, here's the prompts we used, here's the edge cases that we had to go around, and really just like a nice example of like, how do you productionize an LLM use case beyond just like a prototype. So I encourage you checking it out for that. One thing I wanted to call out is, at least in my experience, if you write a really detailed prompt, that can actually pretty quickly get you 80% of the way there. And you might be foolhardy like me and think this last 20% is going to be easy. But like with a lot of things in writing software, the last 20% can be a lot of the work. You might be like, well, like I can get this to work 90% of the time, but like randomly, indeterminately, it doesn't. I gave you some few shot examples. Why are you ignoring them? Maybe I need to change my architecture. So just be aware of it and keep trying. Okay, some other examples. So Salami, I don't know why they named it that. But it uses GPT-4 to turn natural language into Terraform. SemGrep Assistant, you can describe the code you want to find in English, give it a code example of what you don't want to match, some code you do want to match, it'll generate a SemGrep rule for you. Nuclei, which is a sort of a vulnerability scanning tool, has a browser extension where if you're on BugCrowd or HackerOne, you can just say, generate a nuclei template from what's in this bug bounty report. Or you could just be on any website, like Twitter, for example, and just highlight some text and say, try to generate a rule from that. The Orca team also had a blog post about nuclei that showed their sort of online web editor that also has English to rule functionality. So the Microsoft team, so Security Copilot, has some examples of writing English to sort of KQL queries, so sort of their SIM language. Similarly, the Google folks also have some sort of like English to SIM rule as well. Okay, so sort of like taking a step back, what's interesting about this? Probably the tool, perhaps the security tool you're building or using, is very powerful, but there's a learning curve until someone becomes proficient. Is it possible to make someone totally new, use it like an intermediate user, or just otherwise shrink the time to value? And again, it doesn't need to be perfect. I think 80% of the way there is quite great, because it's easier to tweak something that is like mostly what you want than write it from scratch. Okay, I don't know, but if you're like me, you're like, whew, we did it, everyone gets a medal. Let's talk about some resources and reflections. Okay, so speaking of stochastic parrots, I think it's interesting to examine what venture capitalists are seeing. I kid, I know I'm friends with a number of VCs and they're incredibly intelligent and hardworking, and I have no ulterior motives for saying that. But really, they spend a lot of time talking with very smart founders who are building cool things, so I think it's nice to be able to sort of quickly learn from them. So the Menlo Ventures folks have a nice market map of people applying AI to security across AppSec, threat intel, and more. They also have one for securing AI, so how do we use AI securely? The Innovation Endeavors folks have a couple of blog posts about promising applications they see. And Sequoia has a few, not necessarily about security, but this one on the right, so the Gen AI infrastructure stack. So if you're building LLM applications, some of those might be useful to you. They also have one on dev tools. So I think what engineers are doing and where they're innovating is very interesting, and there's probably lots of room for us to learn from them there. And here's a couple more blog posts. Okay, so here's kind of how I think about AI that I'm going to share in case it's useful for you. So instead of thinking, this is going to solve every problem ever, well, probably not, but it can solve some problems in some ways when used correctly. Instead of, if it doesn't respond perfectly every time, it's useless. But, well, if it can help me do my work a bit easier, faster, or more cheaply, that's still quite useful. Rather than saying, let me just add AI to this and it'll be awesome, think, AI is a tool like anything else. The point is to solve real problems. So the exception, obviously, is if you're founding a company and want to raise a lot of money, then, of course, you should add AI to it. And I thought this blog post was a nice illustrative example of some of this. Okay, so if you want to hear more about me interviewing some cool people about AI, I chatted with my friend Daniel Miesler about it here. Also, the Chief Security Officer, Mike Hanley of GitHub. We talked about how he thinks about AI. I also talked with some other really cool people, not about AI, but about building scalable security programs. So Letty from Netflix, Dev from Figma, and Jamie from HashiCorp, and many more. Again, so we didn't talk about securing AI, but if that is of interest to you, my friend Rami wrote a really lovely, very detailed blog post. And actually just this week, we released a new GitHub repo called Prompt Injection Defenses. You can check it out now. And I think it's the best, most thorough collection of here's all the different things anyone has talked about, all in one place. So feel free to check that out. Here's some other people who've written great things about securing AI as well. If you like lists of things, here are some more. If you want to build things that involve agents, there's 3 frameworks that appear the most popular, at least right now. AutoGen from Microsoft, Crew AI, and LangGraph from the LangChain folks. So I think AI isn't taking over everything tomorrow, but it is worth spending time on. AI is probably only going to get better, just like hardware only gets better. The applications you use are only going to get better. I think it's reasonable to believe that in the next few years, AI is only going to get better than it is now. So if you liked a ton of information super densely put in one place, I have a free newsletter that you can check out for tools, talks, and more. And, oh, I accidentally deleted a slide apparently. Okay, so, oh, did they get rearranged? Oh, okay, pretend you didn't see that slide. So a couple of people have chatted online about, is AI going to help attackers or defenders more? And some people think attackers in the short term, defenders in the long run. And I'm still figuring out what I think about it, but I do think that in the long term, security is going to come out on top, or defense, that is. And the reason, I had such a lovely end for you. Still rewind in your mind. So the reason why I think defense is going to win in the end is because I think security is getting better, right? So day to day in the trenches, it can feel like it's not. But if you go back 20 years and think, pretty much any application you could find critical issues in pretty quickly. But today, with modern web frameworks that prevent classes of vulnerabilities from happening in the first place, most of the web is over TLS. We have like YubiKeys, WebAuthn, and things like that is both more secure and easier to use. I think there's still lots of challenges. We're working on it, but I think directionally we're going in a good place. And what I mean to say about that is I think that your work matters, right? The people here watching this or watching it on YouTube later, your work is protecting the photos, private information, and all sorts of other things of millions, if not billions of people in the world. And yes, we have a lot of work to do, but I think that's something to be proud of. I also wanted to say that I think you matter. So I see you and I appreciate you. So thanks so much for your time. It's been my pleasure to be with you today. Here's a link to the slides. And somehow I have time for questions. Ooh.
Everybody, as per usual, we're taking questions via Slido. You can get instructions on how to submit them at bsidessf.org/Q&A. We have one queued up right now from E. Given it is easy to get to 80% but hard to master the last 20%, should we think more about it as an assistant than a replacement?
So should we think of it more as an assistant than a replacement? Yes, I think in the short term it does make sense for it to be an assistant is maybe, given that you may ask it for JSON and 90% of the times it gives you JSON back, but sometimes it doesn't. I think that as an assistant that augments people definitely makes sense in the short term, but I think we're building libraries and frameworks and the models themselves are getting better such that they will be more reliable over time. But given that they can hallucinate today, I think it is safer to have a human in the loop, at least to some extent. But I think it'll get better. Yeah, thank you for your question.
All right, I think that's it for our questions. I'm not seeing any more come in. Clint, fantastic talk. Thank you for ending that on such a positive note. Everyone else, Clint will be around later on.
I'm around for questions. I also have plenty of stickers and a limited number of t-shirts somewhere as well. But yeah, I appreciate your time and attention, and I'm happy to chat here in the hallway or wherever. So have a wonderful rest of your con.